My name is William Hill. I am a staff software engineer at Maraxa. I've been an engineer for 13 years now. This is my second time speaking to BitCon, so I'm excited for it. Yeah, I got to speak last year as well, so really thankful for the BitCon organizing team and Blacks in Tech and at large for having me here again. I'm really excited for it, and we're going to talk about some AI stuff, which again I know we all in tech have been hearing about it, toying around with it and stuff. So I'm gonna jump into some tooling that I've got a chance to play around with, and I think it's pretty cool. So particularly around AI interoperability. So let me share my screen and we'll get started. Um, I can't see my other screen, but let me shift back for a second. Can someone give me in the chat like a note, thumbs up or something? Let me know that they can see my screen share just before I move forward. Okay, cool. Thanks, Jamal. Awesome. Okay, so yeah, we're gonna go over building interoperable systems with AI with a couple of new protocols that has emerged in like the past year. So being MCP, which is Model Context Protocol, and then A2A, which is agent to agent. So we're gonna jump into that. So just a reiteration of who I am. So I said I'm a staff software engineer in Maraxa. Need to update that to 13 years. I'm getting old. But yeah, so that's a little bit of the background of things that I've done over the course of my career. So the goals and expectations for this roughly 45 minutes or so that we have together is want to introduce and talk about these protocols. So talk about them individually and the problems that they solve for interoperability within AI systems. And then when I first was learning about these protocols, I thought they were going to be competing. Um, so excuse me, you can think about like back in the day when it was like web services stuff's coming on. We can hear a lot, REST or SOAP or whatever. But in this case, these two protocols are actually complementary and work really, really well together to kind of solve adjacent problems. What we won't cover is building like an MCP server from scratch or something like that. We won't particularly cover doing that. We will walk through some code and have a live demo. Um, but we also, again, I don't know if some of you heard the conversation we was having before. Things change when it's on the cutting edge. So A to A, I didn't get the full working implementation like I wanted to. I'll definitely cover it and talk about the problem that it solved. But the framework that I'm using made some changes as far as how to implement agent to agent. But we hopefully will still get a good understanding of what it does and the problem that it solves. So let's start a bit of a high level, and this may be, old news to y'all because I'm sure y'all kind of know what AI agents are. But if you don't, AI agents are, essentially pieces of code that use large language models, but they act almost as autonomous pieces of code. So that's one of the powers of them is that they act almost in a way autonomously that they can then collaborate to try to solve a common goal. So typically, when you're creating an agent, you're giving it like a specific task or a specific specialty that it focuses on. And then from there, you can actually build out a team of agents, which then can work together and collaborate and then delegate tasks amongst themselves to be able to solve a higher level problem. So we can see just on a couple of the bullet points there, some of the things that make them stand out and special. They try to reason, let's say quote unquote reason, because it's basically statistical projections or analysis, right? So reasoning as best they can around the digital environment, but they can do some level of planning and breaking down complex goals. They can use tools, which is something that's going to be very important and a key point as we go forward in the talk. So tools being, whether it's accessing external APIs, local file systems, things like that, memory and adaptation. So being able to have like a memory and context as is working through the problem, And as I mentioned, collaboration, where they can then try to delegate tasks to the best available agent to solve a particular problem. So, given that this is a relatively new technology, there's challenges that comes along with that, right? Is it was kind of the wild west as far as like AI agent development. Different companies, whether it was like large enterprises or open source tools, were kind of taking everyone was kind of taking their own approach of how you should build and use agents. So that led to things like led to challenges in interoperability, right? As far as like the kind of point of this talk is that you would have agent isolation. One of the first frameworks that I used to build AI agents was called Crew AI. It was one of the first ones to market that was really well supported. It was open source, had good documentation, but then you also had something like Lang Chain and all that. So everyone's kind of taking their own approach. So if you were building an agent in Crew AI and let's say somebody else or like a teammate was building it in Lang Chain, you didn't necessarily have a clean way for those agents to interact together, right? Which is then kind of like the whole point, as we saw in the past slide, for those agents to be able to have interoperability. So, and then even with the another point that we saw in the last slide, tooling, agents using tools, everybody was then kind of having their own way that you would use tools. So every time you needed to integrate with an external service, it was like requiring custom integrations. So you can almost think about this again, going back to the web server example. Think about if every time somebody was exposing an API, instead of having like the standard REST interface, they were building their own implementation. So every time you needed to go and get external data from somewhere, you had to, it wasn't following a standard. So you had to figure out how to interact with that particular server really every single time that you wanted to create something new because there was no standards around it. So this is where MCP and A2A started to try to come in to solve this problem, is to create standards, which then people could write their own implementation of the standard, whether it's in Python, Go, Java, what have you. But they wanted to put out this standard protocol that then can be used to create tooling. So you can, if you can kind of see at the bottom of the page, and I hope my text is not super small that people can everyone can see it. Like I said, I can't see my chat screen right now, so let me go and check. Okay, yeah. So I don't see anyone say anything. So again, just wanted to try to check and make sure that everyone can see the text. But yeah, it says a good analogy is MCP is attempting to be the USB-C for AI applications. So basically, being that universal connector amongst AI applications and external tooling. So, diving a little deeper into what MCP is. So, it's Models to Context Protocol, but I'll just be using the acronym MCP going forward. So, yeah, it tries to define a universal language and protocol for AI applications that are backed by large language models. So, as we talked about using, again, going back to that um, web example, is thinking there's like REST API. So, we're trying to have a standardized way that these applications can interact with large language models. So this can prevent something like vendor lock-in, right? Because at one point, maybe you had to write, if you were using tooling that was for OpenAI, you may have to write your apps a certain way to interface with OpenAI and the APIs they expose. But then if you want to switch over to Google Gemini or Claude or anything like that, or Perplexity, you may have to completely rewrite how you interacted. Now, MCP is bridging that gap where it's trying to expose a common interface to be able to interact with all of these large language models. So we can see, yeah, tool invocation. Again, very, very important because, as most of us know, large language models only know about the data that they're trained on. So, and whenever you're trying to get it to infer new data that it's not trained on, you can run into things like hallucinations and just faulty data, biases, and all that. So, being able to have a clean interface for tooling to interact with external data sources is also very important, and also memory management, as we talked about. Oh, and I can scroll a little bit. And this one is important too. Is structured context. Is a lot of times the output of large language models are non-deterministic. So you can give it the same exact prompt, and you can get two different. You may get like overall like the same answer, but they can be structured in different ways, worded different ways. So with MCP, you can try to define a specific structure for your data to come back in. It may still not be like completely deterministic, where you get an item totem where your same input is going to give you the same output every time, but at least you can give it a certain structure, especially if you needed that data to pass into like another machine readable context or API or something like that. So, what are some of the benefits of MCP? And I have it broken down by different stakeholders. So, for developers and engineers, we can just be engineers and developers, so we can use those skills that we've already built, working with other systems. So in this case, we can almost treat it like we're just interacting with just a client server model that we're used to, because we now have standardized access for business managers and excuse me, for product managers and businesses. It's a way now to rapidly integrate different data sources. So everybody's trying to figure out how to best use generative AI and such in their business cases. So this provides a way for quicker development, because one of the biggest values that businesses and such are going to get out of generative AI is being able to use your own data, right? Because a lot of businesses has generates a ton of data, and being able to now connect LLMs to all those different data sources they have, whether it's like data lakes, databases, customer resource things like HubSpot, anything like that, being able to integrate with all their various tools and get quickly get information and insights out of it, will provide great value. So data science and researchers, again, working with a ton of data, how can we try to glean information out of the mountain of data they have to typically always deal with? So they get to kind of be able to still use their same data process that they have, but now with the power of large language models, almost as a research assistant, or in this case, agents like a team of research assistants. And then end users, they can be able to get more benefit, and we'll see a couple of concrete examples as we move forward. Like end users, or being able to, let's say a classic one, it's like a travel, trying to book travel. You can type in and say, hey, I want to go to X place, and then that can send a bunch of different agents to interact with different data sources and then create a travel itinerary for you. So, kind of a rehash of the previous slide, but yeah, some of the things that it would enable. So, personal assistant, so agents can be able to access your calendar, create appointments and such. This is one, the web development one particularly sticks out to me as a developer, is being able to, and I've used this before as well, like Figma exposes an MCP server. So if you have like a designer or design team, whatever, if they create some designs, typically it's on the web developers again take that design and turn it to code. Now with like if you're using Claude Code or Cursor or something like that with a Figma MCP server, excuse me, you just pass the link to the Figma design and it basically builds it for you. So it's a lot of cool stuff that can come about out of this, that being able to, like I said, connect disparate tools to be able to work together. So just a bit of the implementation details. We won't go super deep into it, but we'll see a little bit of it once we get into the code. Is some of the concepts of behind MCP. So there's three big participants within the MCP architecture. So you have the host, the clients, and the servers. So the hosts are applications that can actually coordinate with connecting to the servers. So if you've ever used like Cloud Desktop, or you can even pass MCP servers to like ChatGPT. I personally use Cursor a lot with writing my code these days. So you can set up Cursor as an MCP host. So this host basically hosts the clients, and then the MCP clients is what basically makes a one-to-one like constant connection, or one-to-one connection to the server to be able to pass information to the MCP server. And then those MCP servers, they can be hosted locally, which we'll see momentarily in the demo, or they can be, hosted just like, on any other server. And that is basically the bridge between whatever data source you're trying to access. Like I said, with Figma, if we want to think about that as as an example, if my host is Cursor, I can go into the Cursor context and say, hey, um, at this URL, I have a Figma design. I want to turn it into code. So Cursor as the MCP host will instantiate a client, which will then make a connection to the Figma server. And that Figma server will then go and fetch the design data from that particular URL that we described, bring that back into the MCP host, and then start to process that data. And then primitives. So these are things particularly on the MCP server, but it exposes how we can interact with that particular server. So tools is one. So again, if we go back to that Figma example, a tool could be fetch resource, or like fetch design or something like that, or fetch if you have like a icon or something like that. As it's bringing back the data, it could say, that could be a query to like bring back this particular icon that we're going to need to pass back to the MCP host to use in coding that design. And then resources are things where you can then go and query like, databases, API documentation, things like that. And then prompts goes back into what we were talking about, more of that kind of deterministic type of response, where you can give it a consistent template of saying like, hey, um, make our response fit into this format as cleanly as possible. So here's another little diagram of how a MCP server or MCP flow could work. To kind of, again, we already kind of talked about it, but it's just a visual where we could have a MCP host here that has a client. So like I said, in this case, I'm using like Cursor. So if I wanted to then say, hey, I want some information, or I want to operate on some data that's external to my system. So in this case, we see here, and then makes a connection to this MCP server. In this case, these two servers are basically saying just pulling from like a local data source. So this could be on your machine to say like, hey, you going to find like a local file or something. So it goes and finds that file, passes it back to the MCP server, and then back to the client where then it can operate on that external data. And just the same, we see server C. This is connecting to an external service, over the internet. So the MCP server can then define like, um, APIs as far as how to connect to some remote service to get data, to return that data. All right. So again, why does it matter? So it allows us to overcome certain limitations that we already have with LLMs. One is that, like I said, we talked about hallucination, right? Is that it only has knowledge around the data that it was trained on. So in this case, this allows us to be able to go and get external data in a clean and structured way. And also, like I said, now with MCP, we're able to be able to have more dynamic responses. And this is like going to be able to let us bridge the gap to, like I said, and create applications that are more like what we're used to building. Because now we have a consistent interface to be able to go and get external data, whether that's from like databases, APIs, local file systems, or what have you. So that then now allows us to build these AI agents that can interact with the external world, and then bring that data back and pass it amongst themselves to be able to solve a common problem. So that then leads into agent to agent protocol. So you can think about MCP. We talked a lot about communicating with the external world, right? Or with or external sources of data. So A to A solves the problem of the agents themselves being able to communicate. Because If we then go and, with MCP, going to get this external data, let's say we have a crew of agents or whatever, they can go and get this external data, but if they can't pass that data and talk amongst themselves, that leads to a separate problem, right? So this is where the protocols are complementary. So in this case, agent to agent is kind of just like what it sounds like, the agents being able to communicate amongst themselves in a structured way. So, given that the agents are passing data amongst themselves, one of the things is you want to make sure that you're passing data to the agent that think you're passing it to, right? Because again, coming with like security and stuff, if there's like a almost like an agent injection attack, you could be passing potentially sensitive data to a non-trusted agent. So that's one of the things that agent to agent helps solve. It kind of it one allows you to communicate cleanly, but also helps you communicate securely with the data that's being passed among the agent workflow. So some of the challenges it overcomes, like touched on it a little bit, lack of trust and verification, and we'll see how the agents are able to identify one another. So it's almost like service discovery in like a microservice type of environment. We want to break down the silos again because, like I said, different open source or enterprise developers was coming up with how to create agents, but again, not having clean communication channel amongst those different types of frameworks. So now by creating a standard and a protocol, agent written in Google Agent Development Kit may still be able to, cleanly communicate with the agent that was created in Crew AI. And then also, like I said, so this kind of touched on this. We won't have to have all of these bespoke, fragile communications between agents that were developed in, any number of frameworks. And then also, as we talked about, the security and privacy risks. So, some of the key parts of the agent to agent protocol. So, agent cards is one of the big ones. So, each agent creates its own agent card. You can almost think about that as like being the agent's business card. So, it has an ID. It has an endpoint as far as where you can access it. It has its capabilities and skills, which say like, hey, if I'm a sports research agent, I have the capability and skill to go out and fetch data from ESPN.com, basketballreference.com, or something like me as an agent. That's what I specialize in. So if you need that, great. If you need data about the weather, then I'm probably not your agent. You probably need to go on the search within the agent web, agent phone book, whatever you want to call it, for a different agent. So it allows you to say like what this agent specializes in. And then at task, so tasks are pieces of work that with like unique IDs. So if you're familiar with things like task queues, like Reddit or something like that, you can think about these tasks are sent via mess or created from a message, which is the next piece, where it then creates a unique ID task that has its own life cycle that can then work asynchronously until that task is completed. So, for those of you, familiar, like I said, with Redis, Celery, those type of things, those type of task queues, similar type of concept. And then parts, you can send like a text part message to the agent, and they can return to you a response that may have like a data part. And we'll see a bit of an example like on the next slide, where a data part could then basically be a message that's broken up into almost you can think about like a Python dictionary where it has different key value pairs that can then be used like as individual parts of a larger response. And then artifacts, this is within the kind of like generative AI thing, right, where you can generate text or images like multimodal responses. The artifacts that are generated from the responses, well, are called artifacts. So here's just some quick concrete examples of ACA. So like I said, the agent card, you can have like a weather agent. It'll have its identity. It'll have its capabilities as far as I can go get the current weather, I can get the forecast for X amount of days, and so on and so forth. So a message is essentially just like the prompt that you send to the agent, asking like, say, what is the current temperature? And then the parts, that's the response that you can get back. So like I said, the response could be in a data part where it can have like different relevant parts of the response. So you can have the city, like temperature, these in these key value pairs. Like I said, the task. Whenever you send a message, it'll create a new task that can be handled asynchronously because that task can have multiple steps as far as like receiving the query, going out and querying an external, using a tool to query an external data source, formulating a response, and coming back. So each and like it'll have a status as it's moving through those steps, and then the artifact is what's returned back. So I know I've thrown a lot at you. I'm kind of moving kind of quickly, just to, I know for the sake of time. But we also this kind of hammer home that these two are distinct yet complementary. So we can think again, agents communicating amongst themselves, and then MCP is communicating with the external world. But the thing is, agents themselves can use MCP. So you can have a architecture of different agents, and again, we'll see a concrete like an example in a moment where we send a prompt. One agent is maybe it's like the orchestrator agent, the root agent, whatever you want to call it. And it's like okay, I know all the agent cards out there that's available to me in like my known agents or whatever. I get this prompt. Okay, I need to forward this prompt to an agent that's more suited for it. So we forward it to that agent. That agent then can use MCP to go and fetch external data that it needs to solve this particular problem. So, like these, like I said, the agents can speak amongst themselves, and then a particular agent can then use MCP to go out and fetch data that it needs to solve the problem. So, some of the things that we get from the unified approach is we decouple model logic. Like I said, we can basically try to write once and reuse this logic with whatever LLM that we want to use. So we don't have to be locked into a particular vendor of just using Gemini, just using OpenAI, just using Claude or what have you. Is we should be able to write this, and then if we want to swap out for a different model, we should be able to do that. And not only that, is different agents can be backed by with this common interface different large language models. Let's say you have a large language model that's more suited for a particular task. Like there are some, especially like open source models out there that's more suited towards like coding tasks or more suited towards mathematical analysis tasks. Every agent doesn't have to use the same large language model. You can now have these agents to use different large language models that are better suited for the particular task that it's trying to solve. So having these standardized interfaces allows for things like that. Um, so yeah, and I think the one of the most relevant things I've tried to hammer home is not here at the bottom is MCP is you can think about talking to tools or external data sources, and A to A is the agents talking to themselves or amongst themselves and delegating and collaborating. So yeah, almost there. I know, trying to look at the time. Where we're gonna look at just a real world example before we actually get into the code demo. So let's think about an auto repair shop where I'll even tweak it a little bit where it says the customer's personal agent. You can think about like maybe there's an agent that lives in your car where this agent, anytime your check engine light comes on, this agent may get activated and send a request to like your given repair shop. So your check engine light comes on, and it securely communicates with via A to A with the repair shop agent. So it could do different things, right? It may just be like, hey, schedule maintenance, share the details of the vehicle, and then that repair shop agent maybe can send you back an initial request. I mean, your initial estimate. So whenever we send, from our car agent to the repair shop agent then can use MCP to go out and fetch data from its external data sources. One, it may be maybe it needs to interact with their database to say like, hey, do we have this part in stock? Or if we don't, let's go then use a different MCP to make a request to our supplier to say like, hey, we need this part. What's the price and estimated shipping time? So you can have all of this, kind of automated in the way. Headphones I think are dying. But we send a message to the shop's agent. The shop's agent then can go out and get the relevant data it needs to respond to us. And once it does, it then can send that structured response to us that may say like, "Hey, this is what's going on with your car. This is the estimate, and this is when we have service times available." So I'll just quickly talk about Google Agent Development Kit. As I mentioned, when I first started, touring around and building agents, I was using Crew AI, which is really cool. Like I said, open source, well supported, great documentation, a bit more mature. Um, Google's Agent Development Kit, I think, came out earlier this year, and I just wanted to kind of toy around with it and see how it was, and I actually like it a lot. I don't know how many of you heard the conversation before we really got into the presentation, but things change, especially when you're on the bleeding edge. So that's kind of the downside of using it. But one of the cool things we'll see in a moment is that it comes with this web interface for like observability. But yeah, this is a really cool way for building agents. And agent to agent protocol was actually first created by Google, and then they donated, I think, to the is it Apache um, um, foundation. I know it's basically fully open source, and like again Google created, but they donated to where now it's fully in open source and being able to be integrated with other tools. But they also have great A to A support. But also, given that great A to A support, they changed some stuff. So we're not necessarily going to be able to show a full A to A example today, as I'm on a bit of an older version of ADK. But hopefully, you got a good understanding of what A to A accomplishes. So now we're going to jump into a quick code example. For me, using this to try to solve one of my own problems. So, and that sometimes is like, what do I need to wear on a given day? So I'm gonna stop sharing there. Um, Let me now share my code editor.
And just something for everybody in the chat. I've got your questions queued up, and we'll get them asked to William once we get this great demo.
Yeah, so this should be pretty quickly. Sorry, move pretty quick. So, like I said, the PTSO agent for short. Um, the first thing we want to do is do a little bit of data engineering and to show the MCP part of it, right? Is that I have just a simple Docker Compose file here that stands up a Postgres database with some data. So I'll actually show that. Let me reconnect. That's not what I wanted. There we go. So we have two tables in this database. One is for weather, and another is for wardrobe. So with this is a pretty decent approximation to like my actual wardrobe. So I just had it to generate. I just used generative AI to say like, hey, these are some of my favorite brands that I like to wear. Create an approximation of my wardrobe, and from here it has like different pieces of information about the wardrobe, so the garment type, the fabric, um, the season, the style, all this type of stuff. So and then the weather data, I live in Atlanta, so just a simple little thing to go and fetch the current weather. So, the company I work for, we have a tool called Conduit, which is a real-time data tool to be able to go and fetch data. So I'm just going to run that. Again, weather doesn't change that quickly, right? Over the course of a day, but I can say just run. And what this does is this goes out and connects to an external weather API and goes and gets the current weather. So, and I have it fetching every 5 seconds. Again, weather doesn't change that much in really at all in 5 seconds, right? But we can see the temp is basically 65, almost 66 degrees. So if I cancel this, go back to here, refresh. So we see we've added that to the database. So this is going to be important for what we need to do because the PTSO agent we should be able to ask it, hey, what should I wear today? And from there, it should use MCP to go out and connect to this external data source, in this case, this Postgres database, and find the current weather. And then from there, it should then pass that information to the next agent, which is the wardrobe agent, and say, like, hey, given that this is the temperature right now, give me some options of clothes I should wear from this wardrobe. So let's see, let's try to see it in action. So we got the data part, right? So I'll quickly pull up my agent definitions. So fairly short file. I'll try to go through it pretty quickly. Um, we're loading some environment variables, just like API keys. I'm using Gemini in this case. Um, and we first want to set up the tools. So this is setting up the MCP connection. So I have a MCP server for connecting to Postgres, and it's being run by Node. So this MPX. So basically, what this does, it says that create a MCP tool. Oops, let me open that. Create a MCP tool that's going to connect to the Postgres database at this connection string. Same thing here with the wardrobe tools. This is just going to create a variable that we're going to be able to pass to the particular agent. So it's connecting to the same string because as we saw, it's in the same database. So from there, we then are able to define our agents. So in this case, we're going to define our two sub agents first. So we pass in the agent name, the model that we're using. And again, this kind of goes back to what we were talking about, right? That if I wanted to switch this out to use open source model Llama, that's running on my machine, I could. If I wanted to switch it out to use OpenAI GPT-4 Mini or something, I could. This load instruction from file, this is just a helper function where it's instead of me passing in the instruction as far as the structural response I just put it in the file because it's kind of large, so we can just briefly look at the text file. So we're just saying like, hey, you're a helpful weather information agent that provides users with accurate data and time information from different cities, blah, blah, blah. So we try to give it certain guidelines as far as like, hey, this is how you should interact, and this is how you should return the response. So basically putting guardrails, and this is the same thing for the wardrobe assistant. So putting some guardrails around it. So we're telling it the structure, even of the database table that it should interact with. And then we'll see in a second that it actually can then just generate a query, a SQL query from that, which is kind of cool. All right. So we see that for our two agents. Very, very, very similar setup for both of them. The name, the model, the instruction, the tools. So this kind of goes back to what we did here, right? We created those tools. So we passed obviously the weather tool to the weather agent, and then the wardrobe tool to the wardrobe agent. So that sets up our sub agents. And then we have our PTSO agent, which is like our root orchestrator agent. So this is where the prompt comes in, and from there it then delegates what agent should handle which task next. And because we see here it's a bit different, so we have gives a sequential agent. So like I said, I'm on a bit of an older version of ADK, that being Google Agent Development Kit. There's a sequential agent, which means that it should run things sequentially in a certain order. But there's also like what's called an LLM agent, which is more full-on delegation, where it says like, okay, I'm gonna pick and try to delegate which agent should do what next. And sometimes it may not even use every single agent. In this case, I wanted to follow a specific flow, right? I wanted to get the weather and then the wardrobe. So I used the sequential agent. And then, yeah, and then we just set this up as our root agent. So again, under 100 lines of code here. So let me drag this back up. And as I mentioned, one of the cool things about ADK is you get a web interface. So if I just run ADK web, now I can pull this up with localhost port 8000, and we get this little interface here. So And I'm sorry, my headphones just died. Are y'all still able to hear me? Okay. Sorry if there's any ambient noise in the background. Should have charged my headphones, but we move on. We move. So I selected the ADK agent. I can say, what should I wear today? So responds to me. So again, we can get some observability over here as far as what is it doing. So it said, I need to know your location. So I'm in Atlanta. So we can see here, if we go and look, again, like I said, we get some pretty slick observability here. We get like a little graph, like a little DAG here. But we can also see it wrote a SQL query for us to go and select the relevant data from the database. So let me scroll up a little bit. So yeah, it automatically wrote that query for us. So we hit the weather agent first, and it wrote that query to get the data back for us that is 65.75 degrees Fahrenheit in Atlanta. So from there, we see it passes that information back to the weather agent. And then from there, the orchestrator then passes that info to the wardrobe agent. So in this case, it says it knows what the temperature is. And then we can see it generate a second SQL query to hit the wardrobe table. To say like, hey, let's try to fit, let's search for the most relevant clothing we have to fit in this particular temperature. So it goes and does that, hits that query, sends that information back, and then our PTSO agent can then structure the response. So now we can see it gives us both the temperature in Fahrenheit and Celsius for those who are not in America. And then it tells us the range that it falls within, and from there gives us a few different options. Now, again, this response is not always going to be deterministic. It can come back, and like I've seen it come back in several different ways. Where in this case, again, it gives me the brand, gives me the detail, it tells me why, even tells me the care instructions. It can, so give me really just a full outfit. Excuse me. And then for some reason, this ran twice. I don't know why it did that. Stuff happens. But in this case, see the output is actually slightly different, even though somehow this response came back twice. Where this one, it gives me different options as far as like style. Do you want to go business casual today? Do you want to go casual athletic? So it gives me back this response that we tried to tell it to structure and give us back to. So this is kind of slick, right? Like we only did roughly 100 lines of code, and now we could do something where we're interacting with our own data to give us, like I said, this is a me trying to solve my own problem. Sometimes I don't know what to wear on a given day, so I just try to create a little tool that can solve my own problem. So you can think about how this can be applied to a bunch of different other problem spaces. And that's it. I know I am right at time, so let me stop sharing, and yeah, hopefully y'all get something out of that.
Bruh, I'm just going to say that according to what's in the chat and what I'm seeing right now, we're gonna have to do some more of this again in another format. But I know where you are, I know where to find you. So we're definitely going to be calling up on you and making this available to a wider audience. So the questions. So first of all, just logistics. Um, uh, we'll be able to share slides with folks after the conference, but would you be able to put this inside of a GitHub repo, this example for us, so that we can then distribute that too?
Yeah, for
Because
sure.
there's a lot of learning that needs to come from this. Like people need to sit with this and play with this, and I think folks are excited by seeing this. Okay, so thank you for that. So now I'm going to go through some of those questions. I'm going to try to group some of them together, and also folks understand that we may go a little bit over time answering these questions. So apologies in advance for that. So first of all, just some questions about MCP. Has there been a lot of adoption of MCP, or is it still too new to tell right now?
No, I think there's been quite a bit of adoption. And some of it
it's like behind the scenes, right? Where you wouldn't even know. Where it's like being able to even think about like the large language models now. If you go to just like Claude or something like that, being able to paste in, because I remember when I initially started using like ChatGPT and stuff, you can really paste in, say like the URL to a blog post, the URL to, you know, some kind of like new article, and it be able to go and fetch the information and parse it. But now you can. So that's using MCP in the background.
Okay, that is really good for us to know that it's already out there, it's already being used, and a lot of times you just don't even know that it's out there. So another question just about the protocol itself, right? So what protocols are in place so that rogue agents, like, can't do bad things, especially with interoperability, right? This is from Gabrielle. She says she's seen incidents of agents where they delete data or they access sensitive stuff that they're not supposed to be able to have access to, right? So what's in place to stop that rogue behavior from happening?
Yeah, so it's still obviously in development, right? But like things with A2A, that's where it tries to put those guardrails. So with again, I wish I could have gotten the newest and latest and greatest version working, but with those agent cards, one, you can define the skills and the capabilities as far as what it is they can do. So that's a way to try to limit the blast radius, right, of like what they can get access to. So, and even that, say like if there's a agent that there's an open source agent, something like that that you want to use, when you do that, there's even a filter feature that you can put in the agent card to say like, okay, these are the skills that are available. Actually, it's whenever you're connecting to the agent, which in ADK, there's a filter you can put in to say like, okay, you should only have read only access. You shouldn't be able to, do any modifications. You should only, like even if your list of skills mention that, say like if we're taking like a file system agent or something, you can read, write, delete, and all this type of stuff. But whenever I'm invoking you, I want you to only have read access. So they try to put some guardrails around that. Like those things are still in active development, but in the ADK spec, they try to put security features in like that where you can, limit the abilities of the particular agent, where you can only have it to try to do what you want it to do.
Cool. And then there's some questions more about the protocols themselves, right? So it's a question about how does MCP and A2A differ from LangChain, right? Does it simplify the process, or is it some kind of an abstraction that occurs on top of them?
You could almost think about the protocols as being standards, and LangChain as kind of being an implementation is the best way I would kind of phrase it. Where, excuse me, you can implement A2A in LangChain, like from my understanding. Like, because again, like I said, when their LangChain came out, it was one of the first to market. Crew AI and stuff, they were kind of doing things their own way. But these are more standards to say like, all right, LangChain development, if you want to be, interoperable with other type of tooling, because if you have like one company or one team using LangChain, one company using Crew AI, or one company using, or one team using ADK, when it's time to do any type of integration, they may not work together. So by putting a common standard out there to say like, okay, you can write your stuff in LangChain, but whenever it interacts with external tools, it uses this protocol to do so. That's, I think, kind of different. So LangChain is a specific way to write agents that then can communicate using these protocols.
Okay, cool. Next couple of questions have to do with stuff that's in the slide deck. So can we get that back up on the screen, please?
Yes.
And so the first question is on the 10th slide, where you have the MCP server in connection that's there. So so that MCP server, is that connecting to something like a REST API? And that's a question that someone's had. Like, what is that MCP server connecting to?
Yeah. So you, as the creator of MCP server, you define that. So it can connect to a REST API. It can connect to a database. Just like in the example that we saw in the PTSO demo, right? The MCP server was connecting to a database. So whether it's a REST API, GraphQL API, a database, it can connect to a local file server. So you write the code in the MCP server. In this case, I didn't write the Postgres MCP server myself. I just got it from GitHub because somebody else had already written it. All I had to do was pass my connection string to my database. So yeah, it can connect to basically anything that you can, like I said, has a connection string or even just like the MCP server code. You pretty much you can have control over that to connect to whatever data source that you need to.
Okay. Cool. And then with regard to the back end, so basically, so Ralph was asking, can we basically just have all these connections just be on the back end and then the front UI just bring in our artifacts for us? As far as the application, I guess, overall software design.
Could you say one more time?
So can we have on the back end, right? So basically everything that we're seeing right here is like back end stuff for these connections. And then on the front side, we can just have a UI that's bringing in our artifacts.
Yeah. So you can think about, that's where the MCP client is going to come in, where that's written. I think maybe they've evolved it enough where you can write standalone clients, but initially the clients were hosted inside a host. I know it wasn't a great sentence, but they were inside like a MCP host, like I said, like Claude, Desktop, or Cursor, which is the code editor I was using a minute ago. But yeah, you can write your own front ends now to because I know some people use like Streamlit, written in Python, as like a very like just simple chat GPT type of interface. But yeah, there's different front ends you can write out there to like connect to these resources.
Okay. So got four more questions. So William, if you can, just make sure that you in the chat, if you're able to access it, if you could just drop in ways for folks to get in touch with you after this to help with these further questions, because I know there's going to be some more questions after this. So we got four more that we're going to get to right now. So now talking about like tools and knowledge, right? So there was a question about what toolkit can I use to start creating these agents and implementing MCP?
Yeah, so 80K is a good one that I just showed because, like I said, it's good and bad, right? As I mentioned, like one of the best things is that you get that UI where you can really kind of see, because a lot of times what we're doing with agents or LLMs in general is kind of a black box where we don't know what's going on in the background once we send a prompt. So 80K is kind of cool because you can, get a little bit of insight to say like, hey, this is what's happening. Because even one example, when I was building this and trying to connect to my database, it was generating a query, but it was then like, hey, it can't find this. But then, so by opening up that tool and being able to look, I saw it was calling the wrong table name. It was just saying, trying to fetch, select star, what, blah, blah, blah from weather, when my actual table name was weather_data. So that's a pretty cool thing about 80K. As I mentioned, I also use Crew AI as I was first starting it. The one advantage about Crew AI is a little more mature, documentation strong, and there's a lot of resources out there. So whether going to the official documentation, whether going to YouTube, there's courses out there. I know one place I really like is called deeplearning.ai. They have they're all like some really short, informative courses that each one of them you can complete in like really like under an hour. And they have some on Crew AI that was, created by the Crew AI team. So straight from the horse's mouth. So like stuff like that. Those are some ones that I would recommend.
Yeah, I can definitely co-sign on deeplearning.ai. Great source. That's Andrew Ng's kind of learning thing that's there. Also, it looks like just from a tool standpoint, we're Python, SQLite, Olama for running your LLMs, and then the 80K bringing it all together.
Yeah, totally agree.
Okay, cool. And so folks want to know, like, what kind of books and resources that you can recommend for folks who want to dive deeper. And also, if you're trying to upskill, like, what's the path that folks should be looking at to upskill in this area?
Yeah, like I said, deep learning, the AI, again, as we just touched on, is a really good resource. There's a couple of really good YouTubers out there. I'm trying not to butcher his name. I think it's Mervyn Praison. So last name Praison. He puts out really good short videos for upskilling, and he puts out, I feel like, several videos a week on just like all the newest innovations in AI. This one, like, those are free. A paid one that I have that I really enjoy is called Educative. Yeah, it's a paid service. They have a really, really great interactive courses for learning stuff. And then if you would, like, kind of want to do in like the Google ecosystem, Google, they have a lot of code labs out there that are free to use, that are interactive, that you can walk through. It'll walk you through step by step. But especially, like, particularly for like ADK and such. So if you go to the ADK documentation, you'll find like the code labs that are on there. So those are a few off the top of my head that I would recommend.
Okay, and I love this last one. This is a great question, I think, to end on. It's like, how do you balance an AI agent's autonomy with the need for control in production systems?
Oh, that's a good one. That's a really good one. And that's where, like I said, with these two framework or these two protocols, tries to help with that. Because the last thing you want to do is have like security leaks or hallucinations in a production system. So those are the two things that I would say are the most important things that these two protocols try to address. So like I said, trying to put, like, as we looked at those text files that I had, I try to put very verbose instructions around, like, hey, this is what you can and cannot do as far as the agent. Again, not foolproof, but these frameworks are helping get there with better security and better guardrails around what it can and can't do, or can and cannot do, I should say. Oh shoot, I had another thing. I lost it around the A2A part, but those are kind of like the best practices now. And again, these things are evolving rapidly. The protocols are evolving rapidly, and the implementation of the protocols are evolving rapidly. So I think that's one of those questions that's larger than just a one person question, right? So yeah, in that case, you're probably going to be writing your own MCP server. So you will be able to try to define that server to say, like, hey, one, because we haven't even talked about like authentication and stuff like that. I mean, we saw it a little bit with the auth string that I had to pass to connect to my Postgres database, but that's where with the MCP server, you'll be able to write that code to say, like, all right, we can only connect to these tables. You only have read access and stuff. So that's where, like, you have more control. Like, instead of me just going to get, like, downloading an open source server to connect to Postgres, from there you can just follow the protocol of writing your own MCP, because like I said, ADK, Crew AI, and all this type of stuff, they have their own implementation of writing your own MCP server, and from there you can define how exactly to interact with your data source. So if there are sensitive files that it shouldn't be able to touch, it's just like writing a API or something to interact with your database. You only give it access to the data that it needs to know about.
Awesome. Thank you again, William, for being here. We're definitely going to have you back because you got a lot more knowledge to drop on us. So folks, head on over to the next session. Sorry for not giving you enough time for a little break here. But William, if you can, also just put some info in the chat so that folks can get in touch with you and ask more questions later. But But otherwise, see you in some other sessions, folks. Thank you for attending. Thank you again, William.
Thanks, y'all. Yeah, I'm dropping my email, my social media, and my LinkedIn. I just dropped in there. So be happy to answer any other questions.
Cool. All right. Thanks, folks.
Thank you. Thanks for attending. I appreciate y'all.